Hello friends, welcome to my YouTube channel Raghavendra Mysore. Today we are solving Theorem 6.5 from the unit of triangles of class 10. The statement is like this. If one angle of a triangle is equal to one angle of the other triangle and the side including these angles are proportional, then the two triangles are similar. So they are saying that we need to consider two triangles. In those two triangles, one of the angles is equal to the corresponding angle of the another triangle, and the sides which are including those two angles, they are in proportion. Then we need to prove that those two triangles are similar. So with respect to the statement, I have drawn the figure. So I've taken triangle ABC and triangle DEF, where I'm going to consider angle A is equal to angle D. So the one angle of a triangle is equal to one angle of the other triangle. So angle A of one triangle, that is equal to angle D of another triangle, DEF. And the sides including these angles are proportion. So the sides which are including these angles, so the two sides are nothing but one is AB and one is AC. Here the DE and DF. So one is AB and here it is DE, and the other one is AC, here it is DF. Including the sides including these angles are proportion, that is AB by DE is equal to AC by EF. So this is given. What we need to prove? Then these two triangles are similar to one another. What is the condition to prove that two triangles are similar to one another? Nothing but their corresponding angles should be equal to one another, and the sides corresponding sides ratio should be equal to one another. So we will see the given now. So the given is this. What is given in two triangles? Angle A is equal to angle D. The sides ratio, that is AB by DE, is equal to AC by DF. I hope that you have understood with respect to the figure and the statement. Next, what we need to prove? We need to prove that these two triangles are similar to one another. Which are the triangles? That is triangle ABC is similar to triangle DEF. To prove this one, we are doing a small construction, and that is nothing but we are going to mark a point on side DE. We will call this point as P, and we will mark another point on DF side and we will call it as Q. We will join these 2 points by the dotted lines. Now the length of DP is equal to the length of AB, and the length of DQ is equal to the length of AC. So this is our construction. So mark P and Q on DE and DF such that the length of DP is equal to AB and DQ is equal to AC. Now, how to solve this one? How to get the proof here? That is nothing but very simple. First, we need to put this particular PQ line is parallel to EF, and automatically we can say that triangle DPQ is similar to DEF. Then we can show that these two triangles are congruent to one another. Why? Because angle A is equal to angle D, angle side AB is equal to DP, and side AC is equal to DQ. So automatically 3 elements are finished of both the triangles, which are corresponding elements are equal to one another. Therefore, these two triangles are congruent to one another. Then we can prove that those two triangles are similar to one another. So we will start with the proof now. The proof is like this. We are going to take from the given itself. What they have given, that is AB by DE is equal to AC by DF. So AB is equal to what? AB is equal to DP and AC is equal to DQ. This is by the construction we have done here. Therefore, instead of AB, I can substitute it as dP by DE, that is equal to dQ by dF. I am going to take the reciprocal of this one. So DE comes to the numerator and dP goes to the denominator. That is equal to dF goes to the numerator and dQ goes to the denominator. I am going to subtract 1 from on the either side. So when we subtract 1 on either side, in the next step we will be getting dE minus dP, that is by dP, that is equal to dF minus dQ by dQ. So dE minus dP. So you can see here dE minus dP. In dE, if I take out dP, the remaining is PE. In dF, if I take out dQ, the remaining is QF. That is what I have written here. PE by DE, PE by dP, that is equal to QF by dQ. So take the reciprocal once again. So dP by PE, that is equal to dQ by QF. You can see the figure here. dP by PE, that is equal to dQ by QF. It is nothing but this line PQ is dividing the two sides of the triangle in the same ratio. Therefore, this line is parallel to the remaining side by the Thayer's theorem or BPT theorem. Therefore, PQ is parallel to EF. If PQ is parallel to EF, then we know that corresponding angles are equal between the parallel lines. So angle P is equal to angle E and angle Q will be equal to angle F. Why they are equal? Because they are corresponding angles. So if the angles are equal and the sides ratios are proportion, then those two triangles are similar. Now we need to prove that the triangle ABC and the constructed triangle DPQ are congruent. So we are considering those two triangles. Angle A is equal to angle D, that is given, and AB is equal to DP, AC is equal to DQ. This is done by the construction. Therefore, by three elements is equal to the corresponding three elements of another triangle. Therefore, these two triangles are congruent to one another by SAS postulate, two sides and one angle. We already know that DPQ triangle is similar to DEF. Therefore, instead of DPQ, what I can write? I can write triangle ABC because these two triangles are congruent. Congruent means exactly same. Therefore, instead of DPQ, I can write triangle ABC that is similar to triangle DEF. Friends, I hope that you have understood this particular theorem, easiest theorem. If you work out, you can also write. If you like this video, please give a like to the video, share the video, and don't forget to do a comment. If you are new to my channel, please support the channel by subscribing it, and don't forget to press the bell icon. Thanks for watching the video.